I'm gonna set up power real quick. Nice. Start at 9 volts. Alright, so what we have is an 18 gauge primary drive, and I have either end of that drive connected to this cap bank. So it's AC collection, DC output. And then that is connected to this other circuit. So we have 2 transistors here. This is an 18 gauge, this is a 20 gauge, and they're both current limited by this Litz wire coil that's a bifilar 26 gauge coil. So I got one strand basically hooked up to each drive, limiting the amount of current demand for each drive, allowing me to turn the voltage up considerably. If it was just this coil with the 18 and the 20 gauge, I couldn't turn it up past 6 volts without blowing stuff up. But now that I limit the current, we're up to 12 volts now. And we'll get the tap meter. So I broke down my my other table. Yeah, we're above 1,000 RPMs now. $13 volts. Oh yeah. Alright, so it's kind of redundant. It does increase in speed every time you increase the voltage. So far, up to 31 volts. Yeah, you take that number and divide by 8. So it's a little, it's 1125. 1,125 RPMs at 12 volts, 600 milliamps. I think that's pretty good. Let me get this off of the tripod real quick. Hello. All right. yeah. What does that do? The current limiting limits the amount of current that this coil uses. I think it's really neat because you get the mass of this coil, which is, powerful, and you get the current limiting of this coil, which is, it increases the output by a lot. And that's just because the current is limited. You get to turn the voltage up more there's no added resistance on these circuits, so having that extra current limitation is really important. 8 mag rotor, 2 toroid maglev. I'm going to probably reduce it to 1. It'll drop a little bit, but that's okay. It's a little tight on the shaft, but I think it's all right. The bearings are steel ceramic hybrids, and they have one of the ball bearings removed. I believe that helps increase with the speed and mobility. Heck yeah. So there's the remnants of my old setup. I'm taking it down and I'm rearranging everything. Hello. The weight of this is got to be 4.5 pounds on the edge. It's all on the edge. This is a 100% infill. Friction's really low. I'd say it's magleved, and so the reduction in friction is there. It's an 8 magnet rotor, so I mean, anything over 1,000 with 8 mags, I think, is pretty good. I have another rendition of this over here on the ground, right there. It's got 4 mags in it, and I bet you it will go twice as fast as this 8 mag rotor with the same input, at least. And this one's a little bit, has an improvement. I'll show you what it is. See, when I hold it to the side like this, it's even, right? It's level with the boxes where the magnets go. And then this one, the boxes are sticking up 1/8 of an inch. I consider that a mistake, but it's all good. I think it turned out really well. Oh, this is a hot circuit. No, I was getting this. When you're messing with magnets this strong, you should just take your time. See, I got them all lined up here. A round one right there. 2 round ones right there. These are powerful magnets. 2 square ones that actually came together right there. That's going to be hard to get those apart. So when my bearings come, because these are pretty big bearings, it's a 10mm shaft, I'll be able to hook up that rotor. Right now I can only hook up 1 motor at a time. I only have 2 bearings that'll fit the shaft. Oh, it's it's a whole process upgrading from a 1/4 inch shaft to a 10mm shaft. You got to redo all your stuff. This is it's a DC brushless motor. It's kind of it's intricate, okay? There's lots of pieces that fit together that go in like a series that make it what it is. So let's start from like the circuit here at the power supply. And the power supply goes to the 18 gauge circuit, which is over here. And the circuit is 1, 2, 3 for your BCE. Okay? That little rhyme right there. 1, 2, 3 for your BCE. That's pretty cool. Anyway, it goes through that circuit, and then I have this cap bank hooked up to the ends of the 18 gauge strand. So the AC from that pickup goes into the cap bank and virtually, you know, takes all the excess and moves it to the next circuit. And then that cap bank right there powers this circuit, which is 20 gauge. But none of that matters because we've now put on the end of both of those strands, 18 and 20, that 26 gauge Litz wire coil. That's bifilar, so, you know, each strand got, you know, one strand in that coil. So it's limited to 26 gauge current. Because you got to give it some momentum because the trigger coil is so short. It's in this coil right here, and it's only 300 turns of a trigger strand. Yeah, it is an electric motor, but nothing's basic about it. I mean, it's not hard to make or build, but it is definitely a process. And I also tried 32 gauge coil limiting, current limiting. That's basically what I'm doing right now, is finding the best way to run the coils for, like, you know, the cheapest amount. And it's going to be like probably plopping a 32 gauge bifilar on the end that's quite a few turns long, or, you know, like 2 pounds, a pound each. Put it up to 12 volts. I'm cleaning out my closet so that I can move all my artwork in there, store it in there. Almost to 1,000 RPMs right now. There it goes. All right, should we turn it up some more? Let me show you what we're working with for input. That's what the input is right now. And we're above 1,000. Thanks, man. I appreciate you considering this art. That's awesome. Yeah, I would consider it art too. Maybe geometrical, just with the angles anyway. Yeah. Well, I have a lot of art on the walls, not in my room, but all over my house. And then I have like hundreds and hundreds of paintings that I need to put somewhere. So my room's a little bit messy, is what I'm saying. I had it cleaned for a day, and then I'm like, dude, we got to get the closet cleaned out. And I started doing that. Well, what these capacitors do is smooth out the AC to the DC and turn it into usable power. That's what those caps do. So the energy goes into one of these trifilar strands, and then it goes from that trifilar strand to this cap bank, from this cap bank to this transistor, and then that transistor is hooked up to the 20 gauge strand, or the other strand of the trifilar, right? And then the 32 gauge is the trigger strand, and then both of those strands are hooked in series to that one coil over there, which, you know, unites them. But leave that coil out just for right now, because this powers the second one. So without the power going through the first one to cycle through to the second one, it just doesn't matter. But, you know, it doesn't store energy. That's not what these caps do. It's like a throughput. You have to have this thing running in order for this cap bank to work. If you want to run something, you want a super cap bank like that one over there. All right, let's get a reading before we turn it up a little bit. $15 volts, 1 amp, looks like, just under an amp. There it goes. When it starts like running like that, the current goes way down. It just, the current draw like dropped significantly when it loosened up. You could hear it like loosen up and start going a lot faster. I don't know why it's tight like that and getting up to speed, but it's really cool when it lets loose. Yeah, I don't believe in free energy, bro. I just think, you know, if you're gonna call it something else. I've always thought that. I believe in, I don't know, like power, speed, but also it being relatively affordable. Power, I'm saying. Like if I were to take the 26 gauge coil off of this system, like I said, you'd be going really fast, really quick, but you'd be drawing like 2 amps by the time you got to 8 volts. Like, and this stuff that we're using here can't take that kind of amperage. No, I don't even think that. Yes, energy efficiency is a good term. Um, And I'm not saying I want to be the most efficient, like so a Unity or over Unity. I'm not worried about all that. What I mean is I'm interested in power. So, if you're going at least 1,000, then that's good. That's a good place to be. Uh, Mike over at Faraday, he's the one who like kind of like leveled me off, give me a baseline of what I should, aim for. And the 8 mag rotor going 1,000 RPMs is awesome. It's not hard to do, but it's awesome to witness it and like be right next to it, especially if it's a little off balance and it weighs this much. Yeah, it's kind of humbling in a way. I'm glad I built it so good. Like it's very sturdy, or I mean balanced. If there's any like messed up, it's the toroids, the maglevs, and I'm always worried about those things coming unglued. So I tried to have as little amount of material in the middle as possible to make it really light and then heavy on the edge. So give it some flywheel application. But like I said, man, in a video that I did, that like the really good flywheels, the big ones, they can spin for days without power. You know what I mean? This is not what I would consider a flywheel, but it has flywheel application that it will spin for a lot longer, say if it was built a different way. But yeah, man, the flywheel that I saw on this, demonstration of, I forget who it was, the guy from Mythbusters. What's his name? I don't even remember. But he was doing Savage maybe. Wow, that flywheel. It was in a big, huge disc, man. If that thing ever got off the bearings, it would roll through like a whole neighborhood without stopping. Yeah. No, David Duchovny, Matthew Broderick, James. Sorry. Yeah, okay. All right. That's enough. Let's get back on track. All of them. All of them. They all have a part to play. And so do we. So yeah, this is definitely like one of my, I would call it almost a masterpiece because it's built exactly, the way it was. It's one of the six, sorry, a suggestion that was given to me that I believe I followed through on to a T. And the only problem with this build is that the toroid is 1/8 of an inch too low. You can see how the boxes stick up out of the toroid. It's not supposed to do that. That's a lot of drag on the rotor. This one is a much better build, but it's not 100%. It's not 100% infill on the outside, so maybe I should do another 100% one. I don't know. It's hard to tell what to do. All right, we'll start at 9. Gonna turn it on again. Oh, you can hear that. That's nice and healthy. Now this is my second 8 mag rotor, or my third one now. My first one is this axial flux, the big one right there. I'm trying to, reclaim the magnets from it. But, I've been like 9 magnets, 12 magnets, 4 magnets, 3 magnets. I always stayed away from 8 and 6. I have a few 6 magnet rotors, but I don't know. I think 4 is one of the stronger ones, and 3 is definitely strong. For speed, anyway. Now this is awesome for torque, flywheel application. Just smooth. What do you call it? Smoothivity. It's it's a smooth ride. Well, if you're using the fields themselves, the power of the magnet is extremely important. If you're not using the magnet itself, you're using its field, then the strength of that field determines how much torque and power is going to go into each push. Now, if you want to go really, really fast, I suggest lighter magnets, that aren't as powerful. Maybe, I don't know. And it depends really on the build. I've used, let me show you the smallest one I've used. Maybe. Anyway, it's a little 10 millimeter cylinder. Those little tiny ones, man. I love those. Yeah, like that. Is that good? I think it's good. Woo! We are now 13 volts in, 700 milliamps. I think that's doable. That's tolerable. Wow, dude. Okay. Yep, that ran away. Hell yeah, dude. I'm glad this build is... I hope those toroid magnets don't fly off of there. Let me show you this. Almost to 1500. We're creeping up on 15. We need 2 more thousand, basically. Hello, hello. Hey, what's up? What is up? Hell yeah, man. The putt of a good motor. And I can it be better? Yeah, obviously there are a million ways to do this. But I think this is awesome. The current limiting allows me to turn the voltage up, the volume up. Yeah, basically the same thing. Hey, over here, Brandon. What's up, my buddy? Yeah. But with those coils up as close as they are lensing a little bit. Hello. Well, I don't know. If there is a best way to build it, I guess there is that. But then anything in between here and there is, yeah, it's different. That's how I can make 3,600 videos and have them all be different. Hello, hello. What's up, everybody? Welcome. All right, so The cool thing about the coil on the end there that's current limiting is it's a Litz wire coil that's bifilar, equal amount of strands. I think it's 18 strands per line. Yeah, man, it's really cool. You can tell that it's a bifilar. You got two bundles. I smelled that burnt transistor smell just for a second though. So something's hot. I don't know where it's at. Well, maybe it's good. Maybe it was just a... Yeah, yeah. I saw a presentation from God, I forget who it was, but he had an awesome zero force motor. It was a beautiful presentation, but I haven't seen heads or tails of him in a long time. I don't know what's going on there. But one of Kevin's buddies, one of yeah, I told him how awesome I thought that was. It had an optical relay and everything, man. It was sweet. These, unfortunately, are glued down, so maybe I could turn it. No, I don't think it goes that way, though. Not like this. It should go the other way. Like that? Yeah, that's him. Redesign. All right, let me try with 12. It sounded like it was working really good at 20. But let me see if we can get some it might not be high enough to do this accurately. Move it away, you say? Like a half inch, like that? Hello, hello. Well, yeah, the current's not going up, but it's not really kicking that bad or that good. You need more coils? I'm all the way up to 21 volts, though, and it's not even kicking 200 milliamps. That's awesome. Let me try and restart this real quick. Ah, I see what you're saying. So this coil, move it out and leave it as a limiter. And move this one in. Nah, I got no cores, dude. Nope. No. See, it's got, yeah. Yeah, no, none of that. None of that business, man. I'm just um, doing. I'm just resetting stuff up, so I'm not going all out like that right now. And you can see my room is kind of a shambles. I'm just trying to like unwind a little bit while I whistle while I work. Yeah, no cores, especially the random like cores that I would need. Oh, I'll remember. And if I get the right core material, I will definitely try it out again. I think I have powder somewhere, but I'd have to print off a capsule so it can hold it. Thank you. Thank you. Yeah, I think it's pretty cool. Wow, that was at 21 volts. It was at 1.3 amps. So that's pretty good for 21 with the gauges that I'm using. Hello, hello. So I'm gonna let it run at 12 for like a few seconds. No, not a few seconds, like a minute. And then I'm gonna turn it up a little bit till we get to that point where it's like coasting, basically. Thanks, my man. I'll check it out for sure. I like your style. The blue PCBs and all that, man. That's cool. $15 volts, 900 milliamps. Wow. Let me show you. 12 volts, 700 milliamps. I'm trying to get the coils at a good spot now. I think I want to back it off a little bit. But I want to keep that trigger strand in there. It's kind of short. Now it's right up in there. Let's see what the trajectory of the... Yeah, it's going down. So it needs to be backed out a little bit. Just a little bit though. Haha. The flux core? Are you talking about my toroid maglev? It looks like it's on the right trajectory. That position I had the coils in just a while ago was perfect, like awesome. It went into like a runaway phase where it almost reached up to 1500 RPM. That was awesome. I don't want to run it for too long though. I mean, these components are not, industrial really. They're audio components. You want me to move out the coils? Hell yeah, just to see how spinability it is. No, this is a DC brushless motor. But yeah, I can definitely say there's AC in the coils. Yeah, once the DC hits the coil, it becomes AC electricity. You start getting AC electricity as soon as the power goes from the power supply to the coil. And then you can hook up your ends of that coil to a AC collector. And then they can filter it through these bridge rectifiers right here into these DC caps and then out. That's a great mechanism right here. It's fantastic. Anybody spend time in this? Just under 500 RPM still. So yeah, I'm using both AC and DC to power this thing. And that Litz coil is sitting a little high, and if I remove that board there, it's sitting a little low. So I'm thinking I'm going to remove a toroid from its double stack toroid. I'm not going to touch that. I like how it's spinning. And yeah, I'm probably going to end up taping the toroid in, and you know. It does look lopsided there, doesn't it? That's just the glue on the top. I had a toroid on the top, and it was like sandwiching the rotor in between two toroids, but it came unglued. So, and I'm worried about that, the ungluing of everything. But yeah, I'm gonna definitely probably use just one of those magnets. Let me show you the double stack. That's a lot of weight on the rotor. Hello, hello, hello. Derek Mitchell, hello, hello. Like, yes, sir. I have the DC power supply, and then I got the AC manipulator. I got all of it. That's what I would call it, a manipulator, because you're just taking the AC from the wall. There might be a transformer inside there that will boost it by 10 volts, but that's virtually what it is. It's a controller mechanism for the AC in the wall. I love it. No, I think you got it backwards. I know I don't have it backwards. The DC goes into this circuit, okay, through the coil. So it actually goes from the power supply directly into the coil, and then through the coil to the transistor. And by the time it gets over here, it's not DC, it's AC, and I collect it on the ends of these that drive strand. I got it hooked up to this cap bank, the beginning and the end of it, and that's how this transistor gets all of its power. But yeah, it's hard to describe it to the point where you can understand it. I understand that it's complicated. It is kind of complicated because I lack, I guess, the vocabulary to express what's going on here. Look at that thing still spinning, man. That's awesome. Hello, hello. There isn't any output right now. I haven't hooked it up that far yet. This is just a motor right now, not a motor generator. I haven't hooked up any of that stuff yet. wouldn't even call it a pulse motor. It's a DC brushless motor at the moment. Look at that, man. That is awesome. It is still spinning. That is so cool. See, we got it going up pretty fast, like 1,000 RPMs, and then we pulled the coils away and turned it off like 10 minutes ago, and it's still spinning. Yeah, I'm calling Disney. That's not even cool, man. I'm definitely calling Disney. Relating this to the Little Mermaid. That's fricked up, dude. But I agree. It's a motor. It's lonely. It needs its generator, counterpart. Nice. Thanks, Josh. Good to have you. All right, so we got our tri-filar coil that has a 32 gauge trigger, and then it has one of those strands is hooked up to this circuit over here, and then the end of that strand is hooked up to this cap bank, and then this cap bank powers this circuit, which is hooked up to this strand, and then both of those strands are hooked in series to that coil over there, which limits the current. Now I do have a bunch of steel hangers. If I'm going to make a core, I'm probably going to make it out of those. All right, let's turn it on. I'm sure one of my transistors is only half working, but I can't do anything about it right now. So that's 9 volts in, 10 volts in. Yep, 10 volts in, 450 milliamps. We'll let it run like this for just a minute. Hello, hello. That's right. Bonjour, bonjour. Hello, hello. Yeah, these are really good bearings. They're hybrid steel ceramics. They were the fastest ones I could find online. All right. Give it like 30 more seconds, and then I'm going to turn it up to 12. You can hear it still grinding up, like getting faster. Also, it was suggested that I allow my motor to run for 10 minutes before I take any readings. I think that's a good suggestion. Alright, here we go. Up to 12. And we're winding down for now. Got about 5 more minutes of motor fun. Alright, that's good for 12. Let's turn it up a little bit. Here's 15. I'm trying to get it up above 1,000. I don't hear it going that fast right now. Yeah, there we go. There's 1,000. Now that it's going so fast, I'll back them out a little bit because that magnetic field is spreading out away from the rotor. Yay! Now let me show you the input. $20 volts, 800 milliamps. Oh yeah, that's not good. Yeah, well, that in like 1,000, in between 15, I would say 1,500 was my fastest, and that was with 4 mags instead of 8. With this style, this to 10 millimeter shaft and all this new build, that's been my highest is 1,500. Right around 1,000 though. That's where it likes to be. Doesn't really matter what you put into it. Right around 9 volts to whatever else you put into it, it's always going to be, at least for this build, right around 1,000. Can't wait till my bearings get here, man. I'm gonna hook up a 4-magnet one. You would say, why don't you just turn this one into a 4-magnet one? Because I don't want to just. I'm tired, and I don't want to take the risk of having all those magnets just whoosh, come together. So I think I'm gonna leave this one the way it is, and just build new ones. But that's a great hum. That's a great like chug chug a lug a lug a choo choo kind of sound, man. I love it. Almost like a helicopter. There's no representation. It's just a DC brushless motor. It's my rotor design. Very little material in the middle. Kind of flywheel application on the outside. All the mags are on the outside. It's 100% infill on the outside. It's magleved. It's got ceramic hybrid bearings. Like supposed to go like 28,000 RPMs. So I don't know what you mean by representing. I'm representing myself and my ability to do simple math, at least enough to build these. So you just need to know your angles, 45-degree angles, and you can build this. Tinkercad. But here, let's do just a test before I log out here. Hey. Yeah, I'm sorry. And I get like just really I'm passionate about this stuff, so I'm direct. That's all. That was a very hard push. Let's do a very gentle push. This is how I like determine whether or not it's a good maglev is coastability. So yeah, it's really cool. I'm very happy with this. I'm very happy with this one as well. Virtually the same. There's just a few improvements. That's awesome. So that was almost a minute that was spinning, 30 seconds or so. Heck yeah. See, the problem with this one is that the toroid is resting an eighth of an inch below all these boxes. So there's a wind catch there that you can't avoid. But you know, it's really good. And that's why I built the other one, because I corrected that. And I moved this ring in about to the center of the toroids instead of the edge. I like building counter-rotating pulse motors. Ones that have two rotors instead of a stator and a rotor. They're like the ones I've had the most success with in doing, you know, like coming up with something of my own. That's like the best, you know, job that I can do, you know. And I'll go get the base of one that I have. right here. It's got its commutator plate. The outside spins one way, and then the rotor spins the other way. So the rotor will rest in the center. This will go one way, and the rotor goes the other way on a reed switch. And it gets its power from the commutator plates and brushes. But yeah, I made that in like 2 days. I'm like, this is how I want to build it, and I built it, and it worked. You know, it was great. But those are all my clothes, so I apologize for that. I am cleaning out my closet. There's a lot of stuff in there behind this door. So that's going to be a challenge, but I'll get on it and moving forward with all this stuff pretty steadily. All right. Well, thank you very much for hanging out. Really appreciate it. Peace out. Have a wonderful day. Bye now.